Before we begin our quiet journey, take a gentle moment to like this video, subscribe to the channel, and settle in. If you enjoy peaceful storytelling and relaxing explorations of the universe, your support helps this space remain calm, uninterrupted, and free from distractions. Now, dim the lights, get comfortable, and let the soft glow of the moon guide you into a slower rhythm. Tonight, we drift toward the moon, not with rockets or roaring engines, but with imagination, with stillness, with breath. The moon has been humanity's silent companion for as long as we have looked up. Long before city lights softened the stars, long before telescopes sharpened our sight, there it was, luminous, steady, patient, a silver coin resting in the dark velvet sky. The moon is Earth's only natural satellite. It travels around our planet at an average distance of about 238,000 miles. That sounds impossibly far. And yet, in cosmic terms, it is close. Close enough to shape our oceans. Close enough to gently tug at our world. Close enough to feel familiar. If you could drive a car straight upward at highway speed, it would take you months to reach it. If you could fold a sheet of paper 50 times, its thickness would surpass that distance. Space stretches vast and unimaginable. And yet, the moon remains our nearest celestial neighbor. The moon is about 1/4 the diameter of Earth. If Earth were the size of a basketball, the moon would be roughly the size of a tennis ball, small in comparison, yet large enough to dominate our night sky. In fact, it is the 5th largest moon in the entire solar system. Its surface is covered in fine dust called regolith. This dust is the result of billions of years of tiny meteor impacts, each collision grinding rock into powder. The moon has no atmosphere to protect it, no wind to sweep the surface clean, no rain to settle the dust. So every footprint left by astronauts may remain there for millions of years, undisturbed. When you look up at the moon, you may notice dark patches across its face. Early astronomers called them Maria, a Latin word meaning seas. They once believed these dark plains were vast oceans of water. We now know they are ancient lava flows. Smooth basalt plains formed billions of years ago when the moon's interior was still warm and active. The brighter, rugged regions are known as the highlands. These areas are older and heavily cratered. Each crater tells a story of impact, fragments of rock and ice traveling through space at unimaginable speeds, leaving scars that will not fade. One of the most remarkable things about the moon is that we only ever see one side of it from Earth. This is not because it does not rotate, it does. But it rotates at exactly the same rate that it orbits our planet. This synchronized motion is called tidal locking. As a result, the same hemisphere always faces us, as though the moon has chosen a favorite view. The far side of the moon remained unseen by human eyes until 1959, when a Soviet spacecraft sent back the first grainy photographs. The images revealed a landscape more rugged and cratered than the familiar face we see each night. The moon's gravity is much weaker than Earth's, only about 1/6 as strong. If you weigh 180 pounds on Earth, you would weigh just 30 pounds on the moon. Astronauts who walked there described their movements as bounding and graceful, almost like slow motion dancing. There is no sound on the moon. Without an atmosphere to carry vibrations, even the most powerful explosion would be silent. Imagine standing on that gray surface, looking at Earth rising above the horizon, and hearing nothing at all. Only the quiet hum of your own breath inside a helmet. The moon does not produce its own light. It shines because it reflects sunlight. The same sun that warms your skin during the day illuminates the moon at night. Its glow is borrowed, softened, scattered across craters and plains. As the moon orbits Earth, we see different portions of its illuminated half. This creates the phases of the moon: new, crescent, quarter, gibbous, and full. The cycle takes about 29.5 days to complete. A rhythm as old as time. A quiet clock in the sky. Ancient civilizations relied on this rhythm. Many early calendars were based on lunar cycles. The word month itself comes from the word moon. Farmers planted crops by its phases. Sailors navigated by its light. Poets wrote under its glow. The gravitational pull of the moon creates tides in Earth's oceans. As it moves through space, it gently pulls on our planet's waters, causing them to bulge outward. This creates high tide in some places and low tide in others. Without the moon, Earth's tides would be far weaker, and coastal ecosystems would be very different. Scientists believe the moon formed about 4.5 billion years ago. The leading theory suggests that a Mars-sized object collided with the young Earth. The debris from this colossal impact eventually gathered together, forming the moon, a violent beginning for a body that now feels so serene. The moon is slowly drifting away from Earth. Each year, it moves about 1.5 inches farther from us. This gradual separation is measured with lasers bounced off mirrors left on the lunar surface by astronauts. Over millions of years, this tiny drift will add up, subtly changing the length of our days. A day on the moon lasts much longer than a day on Earth. From one sunrise to the next, nearly 29 Earth days pass. This means that lunar nights are also long and cold. Temperatures can drop to negative 280 degrees Fahrenheit in the darkness. During the day, they can rise to 250 degrees Fahrenheit. Extreme contrasts, blazing sunlight, and deep frozen shadow. Despite its harsh environment, the moon has water, not flowing rivers or shimmering lakes, but ice hidden in permanently shadowed craters near the poles. These craters never receive direct sunlight, allowing frozen water to remain stable for billions of years. The first human-made object to reach the moon was Luna 2, a Soviet spacecraft, in 1959. A decade later, in 1969, humans followed. When Neil Armstrong stepped onto the lunar surface, he described it as a giant leap for mankind. His footprint still rests in the dust. 12 astronauts have walked on the moon, all of them during the Apollo missions between 1969 and 1972. They collected rocks, set up experiments, and left behind flags, equipment, and memories etched into history. Moon rocks brought back to Earth revealed that the moon and Earth share similar compositions. This supports the theory of a shared origin. Some of those samples are billions of years old, older than most rocks on Earth, where geological activity constantly reshapes the surface. The moon has Nitocejupili, mountains taller than Mount Everest when measured from base to peak. It has valleys stretching for hundreds of miles. It has craters so vast they can be seen from Earth with small telescopes. And yet, despite all we have learned, the moon remains mysterious. Its quiet presence invites reflection. It reminds us of scale, of how small we are and how connected. Tonight, as you rest, imagine the moon hanging gently above the horizon. Imagine its pale light spilling across calm waters, across rooftops, across forests and deserts. It has watched over every generation before you. It has witnessed the rise and fall of civilizations. It has been a constant in a changing world. Let your thoughts slow with its orbit. Let your breathing match its steady cycle. Inhale softly. Exhale slowly. In the next part of our journey, we will wander deeper into lunar landscapes, explore hidden craters, ancient myths, and the subtle ways the moon shapes life on Earth. If you're enjoying this peaceful exploration, remember to like the video and subscribe to continue drifting through all 500 calming facts about the moon. Settle in, relax, and I'll see you in the next part of our gentle voyage. Before we continue drifting through the quiet beauty of the moon, take a slow breath in and a gentle breath out. If this journey is helping you unwind, remember to like the video and subscribe. Your support keeps the space calm, uninterrupted, and free from distractions. Now let's return to the soft silver glow above us. Imagine standing beneath a perfectly clear night sky. The moon is rising slowly over the horizon, appearing larger than usual. This effect is called the moon illusion. When the moon is near the horizon, our brains compare it to trees, buildings, and mountains. It feels enormous. Yet, high overhead, surrounded by open sky, it seems smaller. The moon itself never changes size in those moments. Only our perception shifts. The moon travels around Earth in an elliptical orbit, meaning its distance from us varies slightly. When it is closest to Earth, we call it perigee. When it is farthest away, it is at apogee. During perigee, a full moon can appear slightly larger and brighter. Many people call this a supermoon. It glows a little more boldly, casting stronger shadows in the night. On rare occasions, Earth moves directly between the sun and the moon. When this happens, Earth's shadow falls across the lunar surface. This is a lunar eclipse. Slowly, the bright face of the moon darkens. Sometimes it turns a deep copper or red color. This reddish glow happens because Earth's atmosphere bends sunlight, filtering out blue wavelengths and allowing red light to reach the moon. Even in shadow, the moon carries the color of distant sunsets. There are also solar eclipses, when the moon passes between Earth and the sun. For a few breathtaking minutes, day becomes twilight. The moon, though much smaller than the sun, appears just large enough in our sky to cover it almost perfectly. This delicate balance of size and distance is a remarkable coincidence. The moon's surface is covered in craters of all sizes. Some are tiny, like pinpricks. Others stretch for hundreds of miles. The largest confirmed impact basin on the moon is the South Pole Aitken Basin. It spans roughly 1,500 miles in diameter. That is nearly the width of the continental United States. This basin formed billions of years ago from an immense collision. Unlike Earth, the Moon has no active weather system. There is no wind to smooth out its landscape, no rain to erode its cliffs, no flowing rivers to carve valleys. Because of this, the Moon preserves its history. Ancient impact marks remain visible for billions of years, like a record written in stone. If you were to stand on the Moon during lunar sunrise, you would notice something unusual. The transition from darkness to light would be slow and dramatic. Shadows would stretch long across the surface. The sun would appear harsh and brilliant against a black sky. Even during the day, the sky would remain dark because there is no atmosphere to scatter sunlight into blue. Stars would not twinkle on the Moon. Twinkling happens because Earth's atmosphere bends starlight. Without an atmosphere, stars would shine steadily and sharply. Space would feel closer, clearer, more intense. The Moon's gravity affects more than just ocean tides. It also subtly influences Earth's rotation. Over long stretches of time, tidal forces have gradually slowed Earth's spin. Hundreds of millions of years ago, a day on Earth was much shorter. The Moon's steady pull has lengthened our days to the 24 hours we now know. At the same time, the Moon stabilizes Earth's axial tilt. Without the Moon, our planet might wobble more dramatically. This stability helps maintain relatively consistent seasons, creating conditions that allowed life to flourish. The Moon is not perfectly round. It is slightly egg-shaped, with its longest axis pointing toward Earth. This shape developed because of gravitational interactions early in its history. The side facing Earth is slightly bulged, forever leaning toward us. Temperatures on the Moon vary drastically between sunlight and shadow. Without air to distribute heat, the surface absorbs warmth directly under the sun and loses it quickly in darkness. This creates one of the most extreme temperature environments in the solar system. Despite its lifeless appearance, the Moon experiences moonquakes. Some are caused by the gravitational pull of Earth. Others are triggered by temperature changes as the surface expands and contracts. These moonquakes can last longer than earthquakes because the Moon's interior is structured differently, allowing vibrations to travel more freely. The Moon's crust is thicker on the far side than on the near side. Scientists are still studying why this difference exists. Some theories suggest uneven heating early in its formation. Others point to large impacts reshaping the interior. The Moon has a very thin and fragile exosphere instead of a true atmosphere. This exosphere contains trace amounts of gases like helium, neon, and hydrogen. The particles are so sparse that they rarely collide. It is almost a vacuum. When astronauts first walked on the Moon, they noticed the lunar dust clung stubbornly to their suits. The dust particles are sharp and jagged, not smoothed by wind or water. They carried a faint smell, often described as similar to burnt gunpowder, when brought back into the lunar module. The footprints left by Apollo astronauts remain clearly visible. There is no wind to erase them, no flowing water to wash them away. Over vast timescales, micrometeorite impacts may slowly disturb the surface, but for now, those first steps are preserved. The Moon's far side has more craters and fewer maria than the near side. This makes it appear rougher and brighter overall. The reason for this imbalance is still being studied, adding to the moon's quiet mysteries. From Earth, the full moon appears bright, but it actually reflects only about 12% of the sunlight that hits it. Its surface is darker than you might expect, similar in reflectivity to worn asphalt. It seems brilliant against the darkness of space, but in reality, it is not highly reflective. The moon's orbit is gradually slowing Earth's rotation through tidal friction. As the oceans bulge and shift, they create resistance against Earth's spin. This energy transfer causes Earth's rotation to slow slightly and pushes the moon farther away. Over millions of years, this gentle dance will continue. Days will grow longer. The moon will drift more distant. The sky of the far future will look subtly different. In many cultures, the moon has been associated with time, transformation, and cycles. Its phases mirror rhythms within nature. The blooming and fading of flowers, the migration of animals, the ebb and flow of tides. The steady return of the full moon has offered comfort and predictability across generations. There are moments when the moon appears during daylight. Pale and you're almost translucent against the blue sky, it reminds us that it is always there, orbiting silently whether we notice it or not. Sometimes, thin clouds pass in front of it at night, creating a soft halo. Ice crystals in high clouds bend the light, forming luminous rings. These halos can feel almost magical, as though the moon is wearing a crown of light. The moon's gravity has shaped not only Earth's oceans, but possibly the evolution of life itself. Tidal pools may have created environments where early biochemical reactions could occur, concentrated and energized by the rise and fall of water. As you continue to relax, imagine floating gently above the lunar surface. The ground below is textured and gray, stretching into the distance. Earth hangs in the sky, blue and white, suspended in blackness. From the moon, Earth would appear nearly 4 times larger than the moon appears from here. Picture that blue sphere slowly rotating. Clouds swirling, continents drifting, all of human history unfolding on that small, radiant world. The moon, in its stillness, has always been a mirror, a reminder of perspective, a silent witness. Let your thoughts slow again. Feel the rhythm of orbit, the steady, patient movement through space. No rush, no urgency, just quiet motion. In the next part of our journey, we will explore more hidden wonders, ancient myths woven around the moon, the science of its inner core, and future missions that may return humans to its surface. If you're enjoying this peaceful exploration of 500 relaxing facts about the moon, take a moment to like the video and subscribe so you don't miss the rest of our gentle voyage. Close your eyes if you'd like, and I'll meet you in the next part, beneath the same calm silver light. Take another slow breath before we continue. If this calm journey through the moon is helping you unwind, gently tap like and subscribe to stay with us through all 500 soothing facts. Your quiet support keeps this space peaceful and uninterrupted. Now, settle back in, relax your shoulders, and let's drift a little farther. Long before telescopes and spacecraft, the moon lived entirely in story. Ancient civilizations looked up at its glowing face and saw meaning written across the sky. In its changing phases, they saw birth, growth, fullness, and fading. The moon became a symbol of cycles, of renewal and return. In Greek mythology, the moon was associated with Selene, a luminous goddess who drove a silver chariot across the night sky. Later, Artemis, goddess of the hunt, was also linked to the moon's glow. To the Romans, she became Luna, whose name still echoes in words like lunar. In ancient China, the moon is tied to the legend of Chang'e, who is said to live there after drinking an elixir of immortality. During the Mid-Autumn Festival, families gather to admire the full moon, sharing mooncakes and quiet reflection under its light. Many indigenous cultures across the Americas named each full moon according to seasonal changes. There was the harvest moon glowing brightly near autumn equinox, the wolf moon of deep winter, the strawberry moon of early summer. These names were not random. They were woven into survival, agriculture, and observation. The moon has always been a clock in the sky. Its predictable cycle of phases allowed early societies to measure time long before mechanical clocks existed. Some of the oldest human-made structures align with lunar movements. Stone circles and ancient monuments suggest careful tracking of moonrise and moonset across seasons. The moon rotates once on its axis in the same amount of time it takes to orbit Earth. This is why we always see the same side. But if you observe carefully over time, you might notice a slight wobble. This gentle shifting is called libration. Because of libration, we can actually see about 59% of the moon's surface from Earth, not just 50. This subtle rocking motion feels almost like the moon breathing. Beneath its dusty surface lies a layered interior. Scientists believe the moon has a small core, possibly made of iron. Surrounding it is a mantle, and above that, a crust. Compared to Earth, the moon's core is tiny, only about 20% of its radius. Seismic instruments left by Apollo astronauts recorded vibrations for years after they were placed. These readings helped scientists understand the moon's internal structure. Some moonquakes were triggered by tidal forces from Earth, others by meteor impacts. Some may even have been caused by the cooling and shrinking of the moon's interior over time. Yes, the moon is slowly shrinking. As its interior cools, it contracts slightly, creating thrust faults on the surface. These appear as small cliffs called scarps. Over millions of years, the moon's face subtly changes, though far more slowly than Earth's ever-shifting crust. The moon has no magnetic field like Earth's global one. However, certain rocks on its surface show signs of ancient magnetism. This suggests that long ago, the moon may have had a magnetic field generated by a molten core. Over time, as the interior cooled, that field faded. Even without a strong magnetic shield, the moon continues to endure constant bombardment from micrometeorites. Tiny fragments of rock and dust strike its surface daily. With no atmosphere to burn them up, they land directly, contributing to the fine regolith that blankets the landscape. The moon's surface smells different than Earth's soil, according to astronauts. When lunar dust was brought inside the spacecraft, it carried a scent often compared to burnt charcoal or spent fireworks. This smell likely came from chemical reactions when the dust first contacted oxygen inside the cabin. If you were to stand at the edge of a large lunar crater, the view would feel vast and dramatic. The rim would curve gently, revealing layers of rock exposed by the impact. At the center of some craters, peaks rise upward, formed when the surface rebounded after being struck. One such crater is Tycho, visible from Earth as a bright point with long streaks radiating outward. Those streaks are ejecta rays, material flung across the surface during impact. They stretch for hundreds of miles like frozen splashes of light. Another prominent crater is Copernicus, named after the astronomer who proposed that Earth orbits the Sun. Through small telescopes, Copernicus appears crisp and well-defined, a reminder that even impacts can carry beauty. The moon's gravity influences Earth in subtle biological ways as well. Some marine animals time their reproductive cycles with lunar phases. Coral reefs often spawn in synchrony with full moons. The rhythm of light and tide creates cues woven into life itself. Humans, too, have long felt connected to lunar cycles. While scientific evidence linking the moon to behavior is limited, its presence continues to inspire art, music, and poetry. The word lunatic comes from ancient beliefs that the full moon could influence the mind. The moon has been a muse for composers and dreamers alike. Beethoven's Moonlight Sonata carries a quiet, reflective quality, much like the object itself. Painters have tried to capture its glow. Writers have described lovers meeting under its light. In 1609, Galileo Galilei turned one of the first telescopes toward the moon. What he saw changed our understanding forever. Instead of a smooth, perfect sphere, as many believed heavenly bodies to be, he saw mountains, valleys, and shadows. The moon was not flawless. It was textured, physical, real. His sketches revealed a world shaped by geology, not divine perfection. It was one of the first steps in humanity's shift toward modern astronomy. As technology advanced, so did our exploration. Robotic missions mapped the surface in detail. Orbiters measured gravitational variations. Some missions deliberately crashed into the moon to study the material kicked up by impact, searching for traces of water. Future missions aim to return humans to the lunar surface. Plans include establishing sustainable bases near the poles where water ice may be accessible. The moon could serve as a stepping stone for deeper exploration, a place to test technologies for journeys to Mars and beyond. But even as plans unfold, the moon remains timeless in our sky. Tonight, if you step outside, you might notice its face. Perhaps it is a thin crescent, like a silver smile. Perhaps it is half illuminated, balanced between shadow and light. Or perhaps it is full and radiant, commanding attention. No matter its face, it carries the same quiet presence. Imagine lying on a blanket beneath it, cool air brushing your skin, the world hushed around you, the moon hanging above, unchanged by your worries, untouched by the rush of modern life. Its light left the surface about 1¼ seconds ago. That is how long it takes for moonlight to travel to Earth. When you look up, you are seeing it almost in real time, a near neighbor in cosmic distance. Let your breathing slow again. Inhale gently, exhale fully. Picture the moon's orbit continuing steadily, night after night. A constant companion in an ever-changing sky. A reminder that even in darkness, there can be light borrowed from afar. In the next part of our journey, we will explore more hidden features of the lunar poles, mysterious lava tubes beneath the surface, and the possibility of future lunar habitats glowing softly against the grey horizon. If you're enjoying this calming exploration of 500 relaxing facts about the moon, remember to like the video and subscribe so you can continue drifting with us. Close your eyes if you'd like, and I'll meet you in the next part under the same gentle lunar glow. Take a slow, steady breath before we continue. If this peaceful journey beneath the moon is helping you relax, gently like the video and subscribe to remain with us through all 500 calming lunar facts. Your quiet support keeps this space free from interruptions. Now, settle in again. Let your thoughts soften and allow the moon to rise once more in your imagination. Tonight, we drift toward the lunar poles. Unlike the equatorial regions we often picture, wide plains and open craters, the poles of the moon hold a different kind of mystery. Because the moon's axis is tilted only slightly, sunlight strikes the polar regions at very low angles. Some crater floors near the poles have not seen direct sunlight for billions of years. These are called permanently shadowed regions. Inside these craters, temperatures remain incredibly cold, so cold that water ice can survive there, hidden in darkness. When spacecraft instruments detected signs of hydrogen in these regions, scientists suspected frozen water. Later missions confirmed it. Tiny grains of ice, mixed with regolith, resting quietly in eternal shadow. Water on the moon changes everything, not as flowing rivers or glistening lakes, but as a resource. Water can be separated into hydrogen and oxygen. Oxygen could help astronauts breathe. Hydrogen and oxygen together could become rocket fuel. The moon, once thought to be completely dry, may help power future exploration deeper into space. Imagine a future base near the lunar South Pole. Low sunlight glancing across the horizon, solar panels positioned carefully to capture energy for long stretches of time. Habitats partially buried beneath regolith for protection from radiation and micrometeorites. Inside, soft lights glowing warmly against the grey landscape outside. Radiation is one of the moon's greatest challenges. Without a thick atmosphere or magnetic field, the surface is exposed to cosmic rays and solar radiation. Any long-term human presence would require shielding, perhaps using lunar soil itself as a protective barrier. Beneath the moon's surface lie ancient lava tubes. Billions of years ago, when the moon was geologically active, molten lava flowed across its plains. As the surface of these flows cooled and hardened, molten rock continued to move beneath. Eventually, the lava drained away, leaving behind hollow tunnels. These lava tubes may be large, some possibly wide enough to house entire cities. Because they lie underground, they could offer natural protection from radiation and extreme temperature swings. In the future, astronauts might live inside these silent caverns, safe from the harshness above. The moon's far side also contains unique terrain. One of its most intriguing features is the far side highlands, covered with craters upon craters. Because it faces away from Earth, it remained unseen until spacecraft revealed its rugged face. There is no dark side in terms of sunlight. Every part of the moon experiences day and night. The far side simply remained hidden from human eyes for centuries. Radio astronomers are especially interested in the far side. Shielded from Earth's radio noise, it could become a perfect location for deep space radio telescopes. There, in the quietest place near our planet, scientists could listen for faint signals from the early universe. The moon also has subtle variations in gravity across its surface. These gravitational anomalies are called mascons, short for mass concentrations. They exist beneath large impact basins where dense material lies under the crust. When early spacecraft orbited the moon, engineers noticed slight changes in trajectory caused by these mascons. Understanding them became essential for safe navigation. Even in stillness, the moon has complexity hidden below. Its surface tells stories not only of impacts, but of ancient volcanic activity. Dark maria formed when massive impacts cracked the crust, allowing lava to flood across low regions. These basalt plains cooled and solidified, creating smoother surfaces than the surrounding highlands. If you look carefully at a full moon, you might notice that the maria form patterns. Some see a face, the man in the moon. Others see a rabbit, especially in East Asian traditions. Human imagination fills the shapes with stories. During the Apollo missions, astronauts left behind more than footprints. They placed scientific instruments designed to measure solar wind particles. Because the moon lacks an atmosphere, solar wind strikes its surface directly. By studying these particles, scientists learned more about the sun's behavior. Astronauts also deployed reflectors on the surface. Even today, scientists on Earth aim lasers at those reflectors. The light travels to the moon and back, allowing precise measurement of the distance between our two worlds. This experiment confirms that the moon drifts away slowly each year. The moon's surface gravity creates interesting motion. When astronauts hopped lightly across the regolith, their movements appeared slow and graceful. Without thick air resistance and with reduced gravity, simple steps became bounding leaps. Watching the footage feels almost dreamlike. If you were to drop a feather and a hammer on the moon, they would fall at the same speed. In fact, during Apollo 15, astronaut David Scott demonstrated exactly that. With no air resistance, objects of different masses fall together, just as Galileo once theorized. The silence on the moon remains one of its most profound features. Without air, there is no sound as we know it. Vibrations cannot travel in the same way. Inside a spacesuit, you would hear only your breathing and the hum of life support systems. Outside, nothing. Even your own footsteps would be soundless unless transmitted through your suit. Earth, seen from the moon, would go through phases as well. Just as we observe lunar phases, an observer on the moon would see Earth waxing and waning. When we see a full moon, the moon would see a new Earth, dark from its perspective. When we see a crescent moon, the moon would see a crescent Earth glowing brilliantly. Earth would shine much brighter than the moon does for us. Oceans and clouds reflect more sunlight. Imagine standing on the moon's surface and seeing that blue sphere hanging above, radiant and alive. The moon's presence has also influenced language. Words like lunacy, lunar, and moonstruck reveal how deeply it has shaped imagination. Even today, we use the phrase once in a blue moon to describe something rare. A blue moon does not usually refer to color. It commonly means the second full moon in a single calendar month. Because lunar cycles do not align perfectly with our calendar, this occasional extra full moon appears every few years. Sometimes, atmospheric conditions can actually tint the moon slightly blue or reddish. After large volcanic eruptions, particles in Earth's atmosphere scatter light differently, subtly altering the moon's hue. The moon has guided explorers for centuries. Before modern navigation tools, sailors used the positions of celestial bodies, including the moon, to determine longitude. By carefully measuring angles and time, they could find their way across vast oceans. As you rest now, imagine the slow rotation of the moon around Earth, both traveling together around the sun, all of it moving through the Milky Way galaxy at incredible speed. And yet, from where you lie, it feels still. That is the gift of distance and scale. The moon reminds us that movement does not always feel like motion, that enormous journeys can appear peaceful from afar. Let your thoughts quiet again. Picture the lunar South Pole bathed in low sunlight, long shadows stretching across crater rims, ice hidden in darkness, a future habitat glowing softly beneath the stars. In the next part of our journey, we will explore lunar dust storms of electrostatic particles, mysterious transient lunar phenomena, and the possibility of mining rare elements from the moon's ancient crust. If this gentle exploration is helping you unwind, remember to like the video and subscribe so you can continue through all 500 relaxing facts about the moon. Close your eyes, breathe slowly, and I will meet you in the next part beneath that same steady silver light. Take a slow breath in and let it go gently. If this quiet journey across the moon is helping you relax, remember to like the video and subscribe. Your support keeps this space calm, steady, and free from interruptions. Now, settle deeper into your pillow, let your thoughts drift, and we'll continue wandering across the silent lunar surface together. The moon may seem still and unchanging, but subtle activity continues there even now. One of the most delicate phenomena on the moon involves dust, not storms as we know them on Earth, but gentle electrostatic lifting. When sunlight strikes the lunar surface, it charges tiny particles of dust. Near the boundary between lunar night and day, these particles can become electrically charged and briefly float above the ground. Imagine a faint, shimmering horizon glow caused by fine dust hovering just above the surface. Astronauts on Apollo missions reported seeing a soft glow near the horizon before sunrise. Later studies suggested this could be caused by levitating dust scattering sunlight. The moon, in its quiet way, has its own subtle movements. There are also reports of something called transient lunar phenomena. For centuries, observers have occasionally described brief flashes of light, color changes, or hazy glows on the moon's surface. Some may be caused by small meteor impacts. Others might result from gases escaping from beneath the surface. Though rare and not fully understood, these events remind us that the moon is not entirely frozen in time. Tiny meteorites strike the moon constantly. Without an atmosphere to protect it, even the smallest fragments reach the surface. When they hit, they create flashes of light that can sometimes be observed from Earth through telescopes. Each impact adds another fine layer of dust to the regolith. Over billions of years, this steady rain of micrometeorites has shaped the moon's texture. The regolith in some areas may be several meters thick, a powdery blanket recording countless collisions. The moon also contains valuable materials. One of the most discussed is helium-3, a rare isotope of helium. On Earth, helium-3 is extremely scarce, but on the moon, solar wind has deposited it into the surface over billions of years. Some scientists believe helium-3 could one day be used in advanced nuclear fusion reactors, potentially providing clean energy. Mining the moon remains a topic of debate and research. Extracting resources in such a harsh environment would be challenging. Yet the possibility continues to inspire engineers and scientists. The moon's soil contains oxygen as well, not in breathable form, but bound within minerals. Through chemical processes, that oxygen could potentially be extracted to support human life or fuel production. Imagine a future where lunar bases harvest sunlight, mine resources, and quietly hum with scientific discovery. The moon could become a testing ground for technologies designed for Mars. Lower gravity makes launching spacecraft easier than from Earth. A lunar outpost might one day serve as a gateway to deeper space. Despite its gray appearance, the moon is not entirely colorless. Up close, its surface contains subtle shades of brown, blue, and even hints of orange in certain regions. These color differences reveal variations in mineral composition. Some areas, rich in titanium, appear slightly bluish in enhanced photographs. The famous orange soil discovered during Apollo 17 surprised scientists. It consisted of tiny glass beads formed by ancient volcanic eruptions. This discovery revealed that the moon once had explosive volcanic activity, not just slow lava flows. Yes, the moon was once volcanically active. Billions of years ago, molten rock rose from its interior and spilled across vast basins. Over time, as the interior cooled, volcanic activity diminished. Today, the moon is considered geologically inactive, though small moonquakes still occur. The moon's gravity also influences Earth's axial precession, the slow wobble of our planet's rotation axis over thousands of years. This wobble affects long-term climate patterns. Without the stabilizing presence of the moon, Earth's climate might shift more dramatically over geological timescales. The moon's orbit is tilted about 5 degrees relative to Earth's orbit around the Sun. This slight tilt is why eclipses do not happen every month. Most of the time, the Moon passes slightly above or below the line between Earth and the Sun. When conditions align perfectly, we witness the breathtaking geometry of an eclipse. The surface of the Moon bears scars from some of the largest impacts in the solar system. Early in its history, during a period known as the Late Heavy Bombardment, massive asteroids and comets frequently collided with the inner planets. The Moon, lacking protective atmosphere and geological recycling, preserves evidence of that chaotic time. Each crater is like a time capsule. By studying their size and distribution, scientists can estimate the ages of different regions. Areas with many craters are older. Smoother regions with fewer craters formed later. The Moon's near side has thinner crust compared to the far side. This thinner crust allowed more lava to flow onto the surface in the past, creating the darker Maria we see today. If you could stand on the Moon during Earthrise, you would witness a sight unlike any other. Because the Moon is tidally locked, Earth would appear almost fixed in the sky from most locations. It would slowly rock back and forth due to libration, but it would not rise and set the way the Moon does for us. The famous Earthrise photograph taken during Apollo 8 captured our planet rising above the lunar horizon. Blue oceans, swirling white clouds, fragile and luminous against the blackness of space. That image changed how humanity viewed itself. From the Moon, borders disappear. Nations vanish. All that remains is one interconnected world. The Moon also influences cultural rituals tied to agriculture. Farmers have long observed lunar phases when planting crops. While scientific support for all such practices varies, the tradition persists, rooted in centuries of observation. The word month comes from moon, reflecting how deeply lunar cycles shaped early timekeeping. Many ancient calendars were purely lunar, following the moon's phases from new to full and back again. A lunar month, the time from one new moon to the next, lasts about 29.5 days. This cycle has guided festivals, ceremonies, and celebrations across cultures. In Islamic tradition, the lunar calendar determines the timing of Ramadan. The sighting of the crescent moon marks the beginning of a new month. Across the world, eyes turn skyward, searching for that delicate silver curve. The moon also plays a role in wildlife behavior. Some predators hunt more actively during full moons when visibility increases. Other animals avoid bright nights to reduce exposure. Even plants may respond subtly to lunar rhythms, though research continues to explore these connections. As you relax, imagine walking slowly across a vast lunar plain. The ground crunches softly beneath your boots, though you hear nothing but your own breath. In the distance, crater rims cast long shadows. Above you, Earth glows gently in the sky. The sun moves slowly, very slowly, across the horizon. Days last nearly 2 Earth weeks. Shadows crawl at a patient pace. There is no rush here, only gradual change. Let your breathing match that slow movement. Inhale gently, hold for a moment, exhale completely. The moon reminds us of patience, of cycles that unfold without hurry, of light returning even after long darkness. In the next part of our journey, we will explore how future astronauts might grow food on the moon, how 3D printing could build lunar habitats, and how the moon may hold clues about the early solar system. If you're enjoying this calming exploration of 500 relaxing facts about the moon, remember to like the video and subscribe so you can continue drifting with us. Rest now beneath that steady silver glow, and I'll meet you in the next part of our quiet lunar voyage. Take a slow breath in and let it drift out gently. If this calm journey across the moon is helping you unwind, remember to like the video and subscribe. Your support keeps this space peaceful, uninterrupted, and free from distractions. Now, allow your body to grow heavier, your thoughts to soften, and let's continue wandering through the quiet future of the moon. As humanity looks ahead, the moon is no longer just a destination from the past. It is becoming a place of return. Space agencies around the world are preparing new missions designed to bring humans back to the lunar surface. Unlike the brief visits of the Apollo era, future plans aim for longer stays, sustainable exploration, gradual presence, a steady rhythm rather than a single leap. One of the greatest challenges for long-term lunar living is food. The moon has no soil as we know it, no rich organic earth filled with nutrients. Lunar regolith is sharp, dry, and chemically different from fertile ground. Yet, scientists have been experimenting with ways to grow plants using treated lunar soil simulants here on Earth. In controlled environments, small plants have sprouted in simulated regolith. With added nutrients, water, and careful management, life can take root even in material that once seemed barren. Imagine a greenhouse on the moon. Transparent panels filtering harsh sunlight, rows of leafy greens growing under artificial lights, water carefully recycled, air enriched with carbon dioxide from astronauts' breathing. A small, vibrant garden glowing against the grey landscape outside. Growing food in space is more than survival. It offers psychological comfort. The sight of living plants, the color green, the quiet act of tending growth. These simple things can anchor the human spirit. Water, as we've explored, may exist as ice near the lunar poles. Future missions may extract and purify this ice, using it not only for drinking but also for growing crops. Closed-loop systems would recycle nearly every drop. Another innovation that may shape the moon's future is 3D printing. Transporting building materials from Earth is expensive and complex. Instead, engineers are developing methods to use lunar regolith itself as construction material. By heating and binding the dust, it can form solid bricks or protective walls. Robotic printers could one day operate before humans even arrive, constructing shelters layer by layer. Rounded domes or partially buried habitats could shield inhabitants from radiation and micrometeorites. Picture a habitat softly illuminated inside, insulated beneath a thick layer of lunar soil. Outside, the surface remains silent and still. Inside, air circulates gently. Screens display Earth hanging steady in the sky. The moon's low gravity presents both advantages and challenges. Moving heavy equipment becomes easier. Launching spacecraft requires less fuel. But over long periods, reduced gravity may affect human muscles and bones. Scientists continue studying how to maintain health in environments with weaker gravitational pull. Exercise equipment, resistance training, and carefully designed routines would likely become daily rituals for lunar residents. The moon may also serve as a laboratory for astronomy. Because it lacks atmosphere, telescopes placed on its surface would not suffer from atmospheric distortion. Images could be clearer, sharper. On the far side, shielded from Earth's radio interference, radio telescopes could listen to faint cosmic whispers from the earliest moments of the universe. In this way, the moon could help answer some of humanity's deepest questions. How did the first stars form? What was the universe like before galaxies existed? Beneath the moon's surface, ancient rock preserves history from the early solar system. Earth's surface constantly renews itself through plate tectonics and erosion. The moon, by contrast, preserves records billions of years old. Studying lunar samples helps scientists understand not only the moon's past, but Earth's as well. The story of our planet is partially written in lunar stone. There is also growing interest in establishing a lunar communication network. Satellites orbiting the moon could provide constant contact between surface explorers and Earth. Navigation systems could help future missions land with precision. The infrastructure of exploration slowly taking shape. Private companies are also joining the effort, developing landers and cargo systems to support scientific missions. The moon is becoming a shared goal, an international collaboration stretching across borders. Imagine future astronauts standing at the rim of Shackleton Crater near the South Pole, the sun skimming low along the horizon, nearby peaks bathed in near-constant light, offering reliable solar energy. In the crater's shadowed depths, ice hidden and waiting, the rhythm of life on the moon would differ from Earth. 2 weeks of daylight, followed by 2 weeks of darkness at many locations. Careful planning required to manage energy and temperature. Technology working quietly in the background to maintain balance. Yet, even in that stark environment, beauty would persist. Stars shining steadily in a black sky, Earth glowing blue and white, shadows stretching long and dramatic across the terrain. The moon has inspired dreams for generations. From early science fiction, imagining lunar cities beneath glass domes, to modern architectural concepts blending practicality with wonder. Some designs envision inflatable habitats expanded upon arrival. Others imagine underground dwellings carved into lava tubes. Each concept balances creativity with survival. The moon's regolith may also contain rare Earth elements useful for advanced electronics. Careful, responsible exploration would be essential to avoid unnecessary harm to this ancient environment. There is an ongoing conversation about preserving certain lunar sites, especially the historic Apollo landing areas. These locations are part of human heritage. Footprints, flags, and equipment remain exactly where they were left. The moon is not owned by any one nation. International treaties declare it the province of all humankind. As exploration increases, cooperation becomes even more important. As you continue resting, imagine standing quietly inside a future lunar habitat. Soft hum of air circulation, gentle glow of interior lights. Outside, endless grey plains under a brilliant sun. Inside, calm voices speaking slowly, a shared sense of purpose. The moon may one day feel less distant. Children born decades from now may see lunar bases as normal. They may study there, work there, look up at Earth as we now look up at the moon. Yet no matter how technology evolves, the moon's presence in our night sky will remain familiar. It will continue to wax and wane, to rise and set, to mark the passage of time with steady certainty. Let your breathing slow once more. Inhale deeply, exhale completely. Picture a small greenhouse glowing on the moon's surface. Plants reaching upward under artificial light. Earth suspended above. Humanity gently extending its reach, not in haste, but in careful, thoughtful steps. In the next part of our journey, we will explore the moon's role in ancient navigation, the mathematics of its orbit, and the subtle gravitational dance it shares with Earth and the Sun. If this peaceful exploration is helping you relax, remember to like the video and subscribe so you can continue drifting through all 500 calming facts about the moon. Close your eyes now, and I'll meet you in the next part of our quiet voyage beneath that steady silver light. Take another slow breath in and let it ease out gently. If this quiet journey beneath the moon is helping you unwind, remember to like the video and subscribe. Your support keeps this space calm, steady, and free from interruptions. Now, allow your mind to drift once more as we continue exploring the moon's timeless dance through space. Long before satellites and digital maps, the moon was a guide. Sailors crossing vast oceans relied on the sky to navigate. By carefully measuring the angle between the moon and certain stars and comparing those measurements with detailed tables, navigators could determine their longitude. This method, called lunar distance navigation, required patience and precision. Yet it allowed ships to cross thousands of miles of open water, guided only by mathematics and moonlight. The moon became both compass and clock. Its steady motion across the sky offered a predictable reference point. Unlike clouds that drift and disappear, the moon followed its celestial path with reliability. The mathematics behind the moon's orbit is a delicate balance of gravity. Earth pulls on the moon pulls back on Earth. At the same time, the sun's immense gravity influences them both. This three-body interaction creates subtle variations in the moon's motion, small shifts that astronomers have studied for centuries. The moon does not orbit Earth in a perfect circle. Its path is slightly elliptical. Because of this, its speed changes as it travels. When closer to Earth, it moves a bit faster. When farther away, it slows slightly. This graceful variation follows the laws described by Johannes Kepler in the 17th century. There is also a gentle wobble in the moon's orbit called precession. Over about 18.5 years, the orientation of the moon's orbital plane slowly shifts. This cycle influences the timing and pattern of eclipses. Ancient astronomers carefully observed these patterns, recording them long before understanding the physics behind them. Eclipses themselves follow predictable cycles. One well-known cycle is the Saros cycle, lasting approximately 18 years, 11 days, and 8 hours. After one Saros period, the Earth, Moon, and Sun return to nearly the same alignment, producing a similar eclipse. Civilizations thousands of years ago recognized this rhythm and learned to anticipate the shadow's return. The Moon's gravitational pull creates not only ocean tides, but also solid Earth tides. Even the land beneath your feet rises and falls slightly due to lunar gravity, by a few centimeters each day. It is a subtle motion, far too small to notice without instruments, but it is constant. Imagine the entire planet breathing gently under the Moon's influence. The Moon also contributes to tidal locking beyond Earth. Many moons in our solar system are tidally locked to their planets. Our Moon is simply one example of this cosmic synchronization. Over time, gravitational interactions slowed its rotation until one face remained turned toward Earth. This locking creates a fascinating effect. From most points on the Moon's near side, Earth would appear nearly stationary in the sky. It would not rise and set as the Moon does for us. Instead, it would hover, slowly rocking due to libration. The far side of the Moon, however, would never see Earth at all. Standing there, the sky would hold only distant stars, the Sun, and occasionally the faint glow of other planets. No blue Earth hanging overhead, only vastness. The Moon's orbit is gradually changing Earth's rotation. Hundreds of millions of years ago, a day on Earth lasted perhaps only 22 hours. The Moon's tidal forces have slowly lengthened our days to the 24 hours we now experience. This process continues, though so gradually that it unfolds over immense timescales. In the distant future, if Earth and Moon remain undisturbed, they could become mutually tidally locked, always showing the same faces to each other. But such changes lie billions of years ahead. The Moon also plays a role in stabilizing Earth's tilt. Our planet tilts at about 23.5 degrees. This tilt gives us seasons. Without the Moon's stabilizing gravitational influence, Earth's tilt might vary dramatically over time, causing extreme climate shifts. The Moon's steady presence has helped maintain relative stability, creating conditions favorable for life. Astronomers have even studied other planetary systems in search of exomoons. Moons around distant exoplanets may also influence habitability. Our own Moon serves as an example of how a satellite can shape the evolution of a world. The light of the Moon has guided more than sailors. For centuries, travelers journeyed at night under its glow. Before widespread artificial lighting, a full moon provided significant illumination. Roads, fields, and paths became visible. Entire communities scheduled activities around lunar brightness. The term harvest moon refers to the full moon closest to the autumn equinox. During this time, the moon rises shortly after sunset for several consecutive nights, providing extended evening light. Farmers once relied on this extra illumination to gather crops before winter. The moon's gentle glow has inspired scientific curiosity as well. By measuring its distance through parallax, observing it from two different locations on Earth at the same time, astronomers calculated its approximate distance centuries ago. Even without spacecraft, careful geometry revealed cosmic scale. Laser ranging experiments today measure the moon's distance with extraordinary precision, within centimeters, by bouncing laser pulses off reflectors placed During the Apollo missions, scientists track its slow drift away from Earth. Each pulse of light travels to the moon and back in about 2.5 seconds. A brief journey across nearly 500,000 miles. The moon also affects Earth's rotation speed in subtle daily patterns. Tidal friction slightly slows Earth's spin, redistributing angular momentum to the moon's orbit. It is a cosmic exchange, energy transferred quietly between worlds. In ancient times, eclipses were often viewed with awe or fear. Without understanding the alignment of celestial bodies, sudden darkness during a solar eclipse could feel ominous. Over time, careful observation transformed mystery into knowledge. Today, eclipses are celebrated as predictable marvels of geometry. The moon shadow during a solar eclipse travels across Earth's surface at incredible speed. Observers within the narrow path of totality experience a few minutes of twilight during the day. Birds grow quiet, air cools slightly, stars briefly appear. Then the light returns. The moon also casts shadows on itself, along the line between lunar night and day, called the terminator. Shadows stretch long and dramatic. Craters appear more pronounced. Mountains stand out sharply. Many astronomers prefer observing the moon near this line, where contrast reveals fine details. If you were to watch the moon carefully over several nights, you would see it rise about 50 minutes later each day. This delay reflects its steady eastward motion in orbit around Earth. Its path across the sky changes with the seasons, climbing higher or lower depending on the time of year and your location on Earth. All of this motion, orbiting, rotating, precessing, unfolds with quiet precision. And yet, from where you rest now, the moon feels serene, fixed, calm. That is the beauty of celestial mechanics. Enormous forces and intricate mathematics producing steady, predictable grace. Let your breathing ease slow again. Inhale softly. Exhale gently. Imagine the moon suspended against a deep black sky, Earth nearby turning slowly, the sun shining from afar. 3 bodies locked in a gravitational dance, billions of years old. In the next part of our journey, we will explore the moon's influence on art and literature, the psychological comfort of moonlight, and the future possibility of lunar tourism. If you're enjoying this peaceful exploration of 500 relaxing facts about the moon, remember to like the video and subscribe so you can continue drifting with us. Rest now beneath that steady silver glow, and I'll meet you in the next part of our quiet lunar voyage. Take a slow, gentle breath in and release it softly. If this peaceful journey through the wonders of the moon is helping you relax, remember to like the video and subscribe. Your quiet support keeps this space calm, uninterrupted, and free from distractions. Now, let your thoughts drift like silver light across still water as we continue. The moon has always belonged not only to science, but to art. Long before telescopes revealed its craters, poets described its glow, writers painted it with words, artists brushed it onto canvas in pale whites and soft blues. the moon became a symbol of longing, reflection, and quiet beauty. In literature, moonlight often represents introspection. A character standing beneath a full moon is often at a turning point, thinking deeply, feeling profoundly. The moon's glow softens the world, blurring edges, inviting contemplation. In paintings from the Romantic era, the moon hovers above forests, oceans, and solitary figures. Caspar David Friedrich often placed small human silhouettes beneath vast skies, reminding viewers of both insignificance and connection. The moon becomes a companion in solitude. Music, too, carries lunar influence. Claude Debussy composed Clair de Lune, meaning light of the moon. Its flowing notes feel like gentle reflections on water. The melody moves softly, like moonlight drifting across a quiet lake. Even without lyrics, it captures the feeling of stillness under a luminous sky. Across cultures, lullabies mention the moon. Parents have sung to children for centuries, pointing toward the glowing circle outside the window. The moon feels safe, familiar, constant. It rises again and again, night after night, like a promise kept. The psychological comfort of moonlight is subtle but real. Unlike the sun's intense brightness, the moon offers gentler illumination. It allows us to see without overwhelming us. Shadows remain soft, colors become muted. The world feels quieter under its glow. Studies suggest that natural nighttime light once shaped human sleep patterns. Before artificial lighting, people often experienced segmented sleep, resting for a few hours, waking briefly during the night, then returning to sleep. The moon may have influenced these rhythms, especially during bright, full phases. Even today, many people feel a quiet pull toward the night sky during a full moon. Some take evening walks, others pause at windows. There is something about its round completeness that invites reflection. The moon has also appeared in countless myths about transformation. Werewolves in European folklore were said to change under the full moon. In other traditions, the moon symbolizes rebirth, waxing from darkness to fullness, then waning again. Its cycle mirrors the natural ebb and flow of life. The phrase "over the moon" has come to mean joy beyond measure. Asking for the moon suggests longing for something distant yet beautiful. Our language carries lunar imagery in ways we rarely notice. In cinema, directors often use moonlight to create atmosphere. A quiet rooftop scene, a silver-lit landscape, two characters speaking softly under its glow. The moon sets a tone that is both intimate and expansive. Even modern photography captures its influence. Long exposure images show the moon's path streaking across the sky. Time-lapse videos reveal its steady climb over mountains or city skylines. Though technology advances, the subject remains timeless. Looking ahead, there is growing discussion about lunar tourism. Private companies are exploring the possibility of sending civilians around the moon, not to land immediately, but to orbit, to see its far side, to witness Earth suspended in space. Imagine gazing through a spacecraft window as the moon's rugged surface drifts below, craters casting long shadows. The far side, hidden from Earth for all of history until the 20th century, slowly turning into view. Lunar tourism may one day extend to brief surface visits. Specialized landers touching down near historical Apollo sites, though carefully preserving them, or near scenic crater rims. Visitors stepping lightly onto the regolith feeling 1/6 of Earth's gravity beneath their boots. Of course, such journeys would require careful planning and strict safety measures. The moon is beautiful, but it is not gentle. Radiation, extreme temperatures, and fine dust present real challenges. Yet the human desire to explore remains steady. The moon could also host future observatories for artists and scientists alike. Imagine a small lunar retreat, a place for research, creativity, and reflection. A quiet outpost where Earth hangs in the sky like a glowing marble. The concept of Earthlight is particularly poetic. Just as moonlight is sunlight reflected from the moon, Earthlight would be sunlight reflected from Earth, illuminating the lunar surface during its night. Earth, with its oceans and clouds, reflects more light than the moon does. Lunar nights touched by Earthlight would glow softly blue. Astronauts on future missions might walk under that faint Earth glow, seeing their home world lighting their path. The moon has also shaped calendars used in religious and cultural traditions. Lunar New Year celebrations begin with the second new moon after the winter solstice. Entire festivals revolve around watching for that first delicate crescent. That crescent moon, thin and graceful, often feels the most fragile, a sliver of silver suspended in twilight. It appears briefly after sunset, then fades, yet it marks the beginning of a new cycle, a quiet renewal. The moon's influence extends even into architecture. Some ancient buildings align with specific lunar events. Certain stone circles frame the moon at major standstills, rare moments in its long orbital cycle when it reaches extreme positions in the sky. These alignments required careful, patient observation over many years. There is something deeply human about tracking the moon. It requires looking up, pausing, noticing subtle change. In a fast-moving world, the moon invites stillness. Imagine lying on soft grass on a cool evening. The moon is nearly full. Crickets hum gently. A breeze brushes past. You watch thin clouds drift across its face, temporarily dimming its glow before passing on. The moon does not rush. It moves steadily, predictably, never hurried. Even when hidden by clouds, it continues its path. Perhaps that is part of its comfort. No matter what happens below, celebrations, conflicts, quiet moments, restless nights, the moon rises. It sets, it returns. Let your breathing slow again. Inhale gently, exhale fully. Picture yourself on a future spacecraft orbiting the moon. Below you, gray plains and ancient craters stretch endlessly. Above, stars shine without twinkling. Earth glows brilliantly in the distance. The moon, once only a distant light, now close enough to touch. In the next part of our journey, we will explore the moon's extreme environments in greater detail. Its longest nights, its coldest shadows, and the engineering required to survive there. If this calming exploration of 500 relaxing facts about the moon is helping you unwind, remember to like the video and subscribe so you can continue drifting with us. Rest now beneath that steady silver light, and I'll meet you in the next part of our gentle lunar voyage. Take a slow breath in, hold it gently for a moment, and let it flow out softly. If this quiet journey across the moon is helping you relax, remember to like the video and subscribe. Your support keeps this space peaceful and uninterrupted. Now, allow your body to grow heavier, your thoughts to move more slowly, and let us continue into the moon's most extreme and fascinating environments. The moon may look calm from Earth, but it is a world of powerful contrasts. On the lunar equator, daytime temperatures can climb to around 250 degrees Fahrenheit. The sun, unfiltered by atmosphere, shines directly onto the surface. Rocks heat intensely. Shadows become the only refuge from the blaze. And yet, only a short distance away, in darkness, temperatures can plunge to nearly negative 280 degrees Fahrenheit. This dramatic shift happens because the moon has no thick blanket of air to trap heat. On Earth, our atmosphere acts like insulation, redistributing warmth. On the moon, heat arrives and leaves quickly. When sunlight strikes, the surface bakes. When night falls, the warmth escapes into space. A lunar night lasts about 14 Earth days. Imagine 2 full weeks of darkness. No sunrise, no shifting twilight, just a black sky overhead, illuminated only by distant stars and the faint glow of Earth. In those long nights, temperatures fall steadily. Equipment must be carefully designed to survive the cold. Batteries require insulation. Electronics need internal heating systems. Survival depends on preparation. Near the poles, however, the story changes slightly. Because of the moon's small axial tilt, certain peaks near the poles receive sunlight for much of the year. These peaks of eternal light are not truly eternal, but they experience long periods of near-continuous illumination. Such areas are prime candidates for future solar-powered bases. Just nearby, deep craters remain in permanent shadow. These shadowed craters are among the coldest known places in the solar system. Some measurements suggest temperatures colder than Pluto's surface. In these frozen pockets, water ice has survived for billions of years. The contrast between blazing sunlight and frozen darkness exists within just a few miles of each other. The moon's surface also experiences radiation exposure far beyond what we feel on Earth. Cosmic rays, high-energy particles from distant supernovae, pass through space constantly. Solar flares can send bursts of radiation outward from the sun. Without an atmosphere or magnetic field to deflect them, the lunar surface is directly exposed. Future habitats must account for this invisible hazard. Thick shielding, possibly made from compacted regolith, could block much of the radiation. Underground lava tubes offer even greater protection. Engineers carefully calculate wall thickness, layering materials to create safe living spaces. Micrometeorites present another challenge. Tiny particles, some no larger than grains of sand, travel through space at extraordinary speeds. Even small impacts can damage equipment over time. Spacesuits and habitats must be reinforced to withstand this steady bombardment. Yet despite these extremes, the moon remains breathtakingly beautiful. Under full sunlight, the landscape appears sharply defined. The sky above remains black, even at noon. There is no blue dome, no drifting clouds, only a stark horizon and the brilliant sun. Shadows are darker and sharper than on Earth. Without air to scatter light, edges appear crisp. A rock casting a shadow creates a deep, inky silhouette. During lunar sunrise, light spreads slowly across the terrain. Because a lunar day lasts about 29 Earth days, the sun rises at a patient pace. Shadows stretch long across crater rims, gradually shrinking as the sun climbs higher. Imagine standing at the edge of a crater as sunlight spills over its rim, illuminating ancient rock formations that have not seen light in 2 weeks. Then, imagine the slow approach of lunar sunset. The sun lowers toward the horizon over many Earth days. Temperatures begin to fall, shadows lengthen once again, reclaiming the landscape. Dust behaves differently on the moon than on Earth. Because there is no wind, dust does not blow in the traditional sense. However, electrostatic forces can cause particles to cling stubbornly to surfaces. Astronauts during Apollo missions found lunar dust coating their suits and equipment. This dust is abrasive, almost like fine glass. It can wear down seals and joints. Managing lunar dust is one of the engineering challenges of future missions. The moon also experiences thermal stress. Rocks expand under intense sunlight and contract in deep cold. Over time, this repeated expansion and contraction can cause rocks to crack and fragment. Even without wind or water, the surface slowly changes. Seismic activity continues quietly beneath the surface. Moonquakes can be triggered by tidal forces from Earth. Some are deep within the interior. Others occur closer to the surface. Though generally weaker than most earthquakes, they can last longer due to the moon's dry, rigid structure. When Apollo astronauts placed seismometers on the surface, they detected vibrations from meteor impacts and internal shifts. These instruments continued transmitting valuable data for years. Despite the harshness, human technology has endured there. Flags planted by astronauts remain standing, though some may have fallen over time due to rocket exhaust during later missions. Lunar rovers sit where they were parked. Scientific instruments rest exactly as they were left. Time moves differently on the moon, without weather to erase footprints, without flowing water to reshape terrain. Human traces linger. If you could stand there during a meteor shower, you might witness tiny flashes as particles strike the surface. Brief sparks of light against a silent horizon. The moon's low gravity would change how you move. Each step would feel lighter. You could jump higher. Objects would fall more slowly. The rhythm of walking would become a gentle bounding motion. Your voice, if you spoke, would not carry through open air. Sound would travel only through your suit's communication system. Silence would surround you completely. And yet, from that quiet place, Earth would shine brightly. Cloud patterns shifting, continents rotating into view, storm systems swirling over oceans. A living world suspended in blackness. The moon's extreme environment challenges us, but it also teaches resilience. Engineers design materials to withstand intense heat and deep cold. Scientists develop systems that recycle air and water efficiently. Each challenge sparks innovation. In many ways, the moon is a testing ground, not just for technology, but for patience and adaptability. Let your breathing slow again. Inhale deeply. Exhale gently. Picture yourself inside a well-shielded lunar habitat during the long night. Outside, the surface lies frozen and dark. Inside, warm light glows softly. Instruments hum quietly. Through a small window, Earth casts a faint blue glow across the horizon. The moon, though extreme, feels calm from this safe place. In the next part of our journey, we will explore the earliest history of the moon, the giant impact that may have formed it, the chaotic early solar system, and how this ancient collision shaped the world you live on today. If this peaceful exploration of 500 relaxing facts about the moon is helping you unwind, remember to like the video and subscribe so you can continue drifting with us. Close your eyes now, and I will meet you in the next and final part of our gentle lunar voyage. Take one more slow breath in, hold it gently, and release it softly. If this long, peaceful journey across the moon has helped you relax, remember to like the video and subscribe. Your support allows this calm space to continue, uninterrupted, free from distractions, and filled with quiet explorations like this one. Now, let's drift into the final chapter of our lunar voyage. To understand the moon completely, we must travel back, far back, to the beginning. Over 4.5 billion years ago, the solar system was a chaotic place. Young planets were still forming. Massive collisions were common. Asteroids and protoplanets crossed paths in unpredictable orbits. Earth itself was young. Its surface was molten in many places. The air was thick with volcanic gases. Oceans had not yet fully formed. Then something enormous happened. A Mars-sized body, often called Theia, is believed to have collided with the early Earth. The impact was unimaginably powerful. Rock vaporized. Debris blasted into space. The collision reshaped both worlds in a matter of hours. From that debris, orbiting Earth in a glowing ring of molten rock and vapor, the moon began to form. Over time, gravity pulled the scattered material together. Fragments collided and merged. Slowly, a new world took shape, born from fire and impact. In its earliest days, the moon was likely covered in a global ocean of magma. This molten surface gradually cooled. Heavier materials sank inward, forming the core and mantle. Lighter minerals floated upward, solidifying into the first crust. This ancient crust became the highlands we still see today. The scars of that violent era remain visible. The moon's surface preserves evidence of the late heavy bombardment, a period when large asteroids frequently struck the inner solar system. Massive basins formed. Lava later flooded some of them, creating the dark Maria. Earth experienced similar bombardment. But unlike the moon, Earth's active geology erased most of those early scars. The moon became a record keeper of our shared history. Without that ancient collision, life on Earth might have unfolded very differently. The moon's gravity stabilized Earth's tilt. It strengthened ocean tides. It lengthened Earth's days. All of these factors influenced climate patterns and possibly the development of early life. In this way, the moon is not just a companion. It is part of our origin story. Even today, scientists continue studying lunar samples to learn more about Earth's earliest days. Isotopic analysis reveals similarities between Earth rocks and Moon rocks, supporting the giant impact theory. Each grain of lunar dust holds clues billions of years old. As the Moon cooled, volcanic activity shaped its plains, lava flows smoothed large areas. Then, over immense time, activity quieted. The interior cooled further, the magnetic field faded, the surface grew still. Yet the Moon never stopped, changing entirely. Micrometeorites continued to fall. The slow drift away from Earth continued. Tiny moonquakes rippled through its crust, subtle, patient transformations. The Moon's relationship with Earth remains dynamic. It continues to raise tides. It continues to slow Earth's rotation by fractions of a second per century. It continues to move away at about 1.5 inches each year. One day, far in the future, the Moon will appear smaller in Earth's sky. Solar eclipses, as we know them, where the Moon perfectly covers the Sun, will no longer occur. The Moon will appear too small to block the Sun completely. But that day lies hundreds of millions of years ahead. For now, the balance remains exquisite. The Sun is about 400 times larger than the Moon, but also about 400 times farther away. This coincidence allows total solar eclipses to occur, brief moments when the Moon's disk fits the Sun almost perfectly. Such alignments feel almost poetic. As we reach the end of this journey, imagine standing on a quiet shoreline under a full moon. Waves roll in gently, pulled by lunar gravity. Silver light stretches across the water in a shimmering path. The air is cool. The world feels calm. The same moon that formed from ancient fire now lights peaceful nights. It has watched over dinosaurs and glaciers, over ancient forests and rising cities, over every generation of humanity. It has been constant through change. Perhaps that is why it comforts us. When life feels uncertain, the moon still rises. When days feel long, the moon still waxes and wanes. Its cycle reminds us that nothing stays dark forever. Light returns, always. Imagine now day drifting upward, rising gently into space. Earth and moon suspended together, orbiting the sun moving through the galaxy drifting through the cosmos. Motion everywhere. Yet from afar, all seems still. The moon, born of collision, now a symbol of calm. Its craters no longer violent scars, but quiet patterns. Its grey plains no longer molten, but serene. Its silence no longer empty, but peaceful. Let your breathing slow once more. Inhale deeply, exhale completely. You have traveled from ancient impact to future lunar habitats, from myths and music to mathematics and exploration. 500 gentle facts woven together beneath a steady silver glow. And as you rest now, perhaps on the edge of sleep, remember that the moon will be there tonight, hanging softly in the sky, unhurried, unchanged by the noise of the day. If you enjoyed this relaxing journey through 500 facts about the moon, remember to like the video, subscribe to the channel, and share it with someone who could use a peaceful night's rest. Your support keeps these calm explorations free from adverts and full of quiet wonder. Close your eyes now. The moon is rising, and it will rise again tomorrow.